In this physics tutorial, you will learn 1. What is a unit? 2. Why do we need units? 3. Why it is necessary to have commonly accepted systems of units. 4. Which are the main systems of units used in science and daily life? 5. What is the difference between the fundamental and derived units? 6. What are multiples and submultiples of units? Introduction to units and systems of units. Let's start by considering a practical example that you could do at home. Suppose you are told to measure the length of your sitting room but you don't have any measuring tool at home. Therefore, you decide to go at the garden and take a stick you found there. The stick is quite straight, so you think it is fit for this task. You take the measurements and obtain a result, let's say 8 sticks long for the length of the sitting room. However, your sister doesn't approve this method of measurement. She decides to use her pencil to measure the room's length. After taking the result, she finds the sitting room of your house is 27 pencils long. If the person who told you to take the measurements asks about the result, he will get confused when hearing 2 different versions of the answer. Which of you is right? Why? Despite the fact you have obtained 2 different results, you are both right if you made correctly the process of lengths measurement, i.e., if you measured the required length in a straight line, or if you placed the rod or pencil at the ending position of the previous measurement, etc. Hence, there's something else that is wrong here. Can you guess what? We will try to answer this question and many others in the following section. What is a unit? Why do we need units? Why it is necessary to have commonly accepted systems of units. In physics, a unit is a widely accepted standard of measurement. Given the confusion arisen due to the use of many methods of measurement for the same thing in different parts of the world, scientists decided to hold a meeting in which they established a commonly accepted method in measuring things. The aim was to allow all people around the world to understand the result of a certain measurement. In addition, and most importantly, it allows the use of the science books published in different countries with the sharing of information in a common standard that can be replicated. Nowadays, many processes in daily life use universal operating standards. If the RAM of your laptop is faulty, you can easily replace it as many different laptop brands use the same type of RAM. All types of debit cards are same size, so they all fit a given ATM wherever it may be located. COVID-19 tests work the same for all people around the world, regardless their nationality, race, gender, etc. These and many more examples show the importance of the standardized methods. Units are one of the most classical examples in this regard. A correct result of a measurement must contain 2 elements, the magnitude of measurement and the unit of measurement. You cannot say, the length of my scarf is 82. The person who is hearing you will immediately reply, 82 what? Also, you cannot say I have a pendant which is some cm long. In both cases, the information you are giving is not complete. You must say, the length of my scarf is 82 centimeters and I have a pendant which is 52 centimeters long if you want to provide a full information of what you are referring to. What are the main systems of units used in science and daily life? There are 2 main systems of units used in science and daily life today, 1. The SI system of units and 2. The imperial system of units. The first one is recognized in science and technology while the other is mostly used in daily activities in English-speaking countries. In the next segment, we will discuss the most important features of each system of units. The SI system of units. By definition, units are classified in 2 main categories, A. Fundamental and B. Derived units. Fundamental units are considered as each of a set of unrelated units of measurement, which are arbitrarily defined and from which other units are derived. Thus, it is obvious that all derived units are obtained by the combination of 2 or more fundamental ones. In this regard, the meeting we discussed before, in which the most well-known scientists around the world discussed setting up a commonly accepted system of measurements and units, established 7 fundamental units. They are: Point 1. The meter, it is used to measure length. 2. The kilogram, it is used to measure mass. 3. The second, it is used to measure time. 4. The ampere, it is used to measure electric current. 5. The Kelvin, it is used to measure temperature. 6. The mole, it is used to measure amount of substance or particles in matter. 7. The candela, it is used to measure light intensity. There are also two supplementary units which are neither fundamental nor derived. They are the radian. It is used to measure the amount of surface area enclosed by an angle's boundary lines, and the steradian, symbol, SR, is used to measure the amount of space bordered by a solid angle. The other units not included in the above list are all derived. As stated before, they are all combinations of two or more fundamental units. For example, the unit of area is a derived unit as 1 meter squared equals 1 meter, although there is only the unit of length mentioned here. The square meter is a derived unit because the meter here is mentioned twice, i.e. there is a combination of meter and meter itself. Or, the unit of speed is derived as it is obtained by the combination of two fundamental SI units. The imperial system of units. The differences between the imperial and SI systems of units consist in the units of length and mass. The other units are the same. Thus, in the imperial system of units, the unit of length is the yard. The conversion factor between yard and meter. The conversion factor is 1 pound equals 0.4536 kilograms. Example 1. Convert the following units into the required ones. Solution. The conversion factor between yard and m is 1 yard equals 0.9144 meters. This means 1 meter equals 1 divided by 0.9144 yards equals 1.09 yards. Likewise, the conversion factor between pounds and kg is 1 pound equals 0.4536 kilograms. Thus, 1 kilogram equals 1 divided by 0.4536 pounds equals 2.20 pounds. Therefore, we have In addition to the two above-mentioned systems of units, there is also another important system which is based on the first three SI units, i.e. the units of length, mass and time. This system is known as the CGS system. As you see, the only difference with the SI system is that it considers as units two submultiples of the corresponding SI units. The rest of the quantities in both systems are the same. The CGS system is particularly useful when dealing with small amounts of materials or with physical quantities such as density, liquid pressure, etc. What are multiples and submultiples of units? Multiples and submultiples are the prefixes that we frequently use to express or show quantities in scientific terminology. We use the Greek terms to write the multiples and submultiples in words and standard notation to express them in numbers. Some of the most important multiples and submultiples are shown in the table on screen. As you see, when approaching the unit, the divisions become finer. However, prefixes such as hecto, deca, dec and centi are not officially recognized in the SI system. When we appoint a certain unit to a prefix, we obtain a multiple or submultiple of the unit itself. Thus, if we say 1 micrometer, we understand a length equal to 1/millionth of a meter. If we say 1 milligram, we understand a mass equal to 1,000th of a gram or 1/millionth of a kilogram, and so on. The generic rule of SI units is that the units change by powers of 10. Only for the multiples of the unit of time we use different rules. Thus, 1 minute equals 60s, 1 hour equals 60 minutes, 1 day equals 24 hours, and so on. In this case, the base 12 numerical system is used for historical reasons. On the other hand, the submultiples of second obey to the powers of 10 rule. We can say millisecond, microsecond, nanosecond, etc. As for the imperial system of units, the conversion rules are different. Thus, for the units of length we have. As for the units of mass in the imperial system of units, we have Example 2. A French tourist is shopping in London. He wants to buy some oranges. The price of the oranges is 0.80 per pound. How many kilograms of oranges can he buy with 20? Solution. First, let's calculate how many pounds of oranges the tourist can buy with 20. Now, let's convert pounds to kg using the known conversion factor. Summary. In physics, a unit is a widely accepted standard of measurement. A correct result of a measurement must contain two elements, the magnitude of measurement and the unit of measurement. There are two main systems of units used in science and daily life today: 1. The SI system of units. 2. The imperial system of units. The first one is recognized in science and technology while the other is mostly used in daily activities in English-speaking countries. By definition, units are classified in two main categories: A. Fundamental and B. Derived units. Fundamental units are considered each of a set of unrelated units of measurement, which are arbitrarily defined and from which other units are derived. Thus, it is obvious that all derived units are obtained by the combination of two or more fundamental ones. There are 7 fundamental units in the SI system of units. There are: the meter, it is used to measure length; the kilogram, it is used to measure mass; the second, it is used to measure time; the ampere, it is used to measure electric current; the kelvin, it is used to measure temperature; the mole, it is used to measure amount of substance or particles in matter; the candela, it is used to measure light intensity. The differences between the imperial and SI systems of units consist in the units of length and mass. The other units are the same. Thus, in the imperial system of units, the unit of length is the yard. The conversion factor between yard and meter, which is the corresponding the unit of length in the SI system, is 1 yard equals 0.9144 meters. The unit of mass in the imperial system is the pound. The conversion factor is 1 pound equals 0.4536 kilograms. Multiples and submultiples are the prefixes that we frequently use to express or show quantities in scientific terminology. We use the Greek terms to write the multiples and submultiples in words and standard notation to express them in numbers.